Okay. All right, guys. Today we're going to tie together some of the key concepts we've been working on. We've got acceleration, static friction, and non-equilibrium all together in this kind of classic problem. Guys, on the flatbed truck over here, we're going to have a 10 kilogram cinder block, and we have a 100 kilogram cinder block. They're sitting on this flatbed truck, and the truck's going to take off accelerating that way. Now we already learned, because of Newton's first law, that object has inertia. This object has more inertia, because inertia is a measure of the tendency of an object to keep doing what it's doing, and the unit of that is mass. And so as the truck takes off, these guys are going to want to stay where they're at. The only thing that's going to propel them forward is the force of static friction between them and the truck bed. And so we've got to kind of figure out a couple questions about this. And if we come back over here, it says the coefficient of static friction between the cinder blocks and the bed of the truck is 0.42. And so therefore we're going to look at these two big questions. Will both the blocks begin to slide at the same truck acceleration? Okay, so that question is basically, will these blocks both take off sliding at the same time? Will the heavier one slide first, or will the lighter one slide first? So we're going to take a look at that. And then number two, what is the maximum acceleration the truck can have before each of the blocks begins to slide? So let's go ahead and look at that, guys. The main force, the only force that's going to cause these things to accelerate is the force of static friction, max. So we can go back to Newton's second law. We can say the sum of the forces is equal to mass 1 times acceleration, if we're talking about the 10 kilogram block. Now, we talked about earlier that the force that's actually causing it to accelerate is the force of static friction. So we could say Fs equals, or I'm sorry, Fs max equals m1a. If we plug in the equation for Fs max, we're looking at mu static times the normal force. And in this case, since we're on a flat horizontal surface, the normal force is going to be equal to the weight of the block. So let's go m1g. And so we can say that equals m1a. Now guys, this basically kind of gets us to the point, at least on this one, and we'll look on the other one as well, where we can see that the masses are going to cancel out. And when that happens, that kind of answers our first question. Will both blocks begin to slide at the same truck acceleration? Well, if we're able to cancel out the mass, that basically goes away. Mass does not play a part in this. So we know that mu(s) is 0.42. We know the acceleration due to gravity is 9.8. And so we can come up with the maximum acceleration the truck can have before it breaks over that static friction and the block begins to slide. So if we look at that, we say A equals, we multiply that together, we come up with a value of about 4.116 meters per second squared as the truck's acceleration. It's going that direction from the drawing up there. Okay. Now, if we move over and look at the 100 kilogram block, I think we're going to see the same sort of thing, but let's go ahead and work our way through it. We got Fs max, same thing, equals m2a, and we got mu(s) times Fn, or mg, and in this case it's m2g, and so we have m2a. Once again, the masses cancel out, and we are going to be left, guys, with that same, oops, let's go here, let's go 0.42 times 9.8 times a. And if you see, it's exactly the same as we have over here, so we can say acceleration equals 4.116 meters per second squared in that direction. So guys, when it boils down to it, the answer to question number one, will both blocks begin to slide at the same truck acceleration? The answer is yes. And what is the maximum acceleration the truck can have before each of the blocks begins to slide? It's 4.116 meters per second squared. So that ties in the concept of non-equilibrium, because whenever we have non-equilibrium, the sum of forces instead of equal to ma. It ties in friction, because friction is the component that supplies the force for acceleration. And then acceleration, tying into Newton's second law, putting that all together. So one little thing that I would say, a common thing that's going to happen in a lot of our problems is you're going to set these things up. You won't know sometimes the mass, but guys, a lot of times the mass is going to cancel out, and so the mass won't matter in your problem. So that's acceleration, static friction, and non-equilibrium example.